All right, let's look at this problem of parameterizing the intersection of two planes. And particularly here, uh, we want to point out that those two planes are given by those two equations. You'll just copy them a little bit. Find this is the question 2 prime. Find parameterization of two planes x plus y plus z equals 5 and 5x minus 2y equals z equals -6. So we do know those two planes are not parallel to each other. How do we know? Because they're normal vector, right? So the normal vector for this first plane is 1, 1, 1. And the normal vector for the second plane is 5, -2, 1. And those two vectors are not parallel to each other. So the two planes are not parallel to each other. And they will be intersecting at some line, right? So we need to parameterize the line. So how do we do that? Maybe we should recall. How do we parameterize a line? Remember, R of t equals OP plus t times the direction vector, v, right? Okay, so we do need two information. So we need t and v. So which one is easier? Well, I guess the second one, v, is easier, maybe. V is the direction vector. Point is a point on the line. So V is the direction vector, P is a point on the line. So how do we get the direction vector of the line? Well, one thing we should be recognizing. So this is supposed to be the first plane, P1. And how about we have another plane, P2, and this line over here is the line of intersection. And what is the feature? Remember, here, this is a first normal vector, and this is the second normal vector for the second plane. So this line over here, the line of intersection. So key observation. Key point, key fact, I mean. Direction V is perpendicular to both N1 and N2. So how do we get the vector that is perpendicular to both vectors? So V is going to be obtained by N1 cross N2, which is I, j, k, and y is 1, 1, 1, and 2 is 5, negative 2, 1. Then we get the direction vector. So now we just need to compute. So let's use the notation of the color we used before. Okay. Minus j. Okay. This is 1, 1, 5, 1. And the last one is k. Okay. This is 1, 1 again. 5, negative 2. So this is the direction vector, which is I times 1 times 1 minus negative 2 times 1 minus j times 1 times 1 minus 5 times 1 plus k times 1 times negative 2 minus 5 times 1. So this is I times and 1 plus 2 is 3 minus j times 1 minus 5 is negative 4 plus k times and negative 2 minus 5 is negative 7, which is 3i plus 4j minus 7k. Or in the components form, so this is the direction vector. How about the point P? P is on both plane. So the P point, x naught, y naught, z naught, satisfy both equation. The two equations are this and this. Okay, so we solve them together. Um, 5x, sorry. But again, we have three variables, only two equations. So one trick is we only need, we could set value to one of those variables, either x, y, or z. We could set x to be 0, for example, to make things easier. Then, what is happening? What we're getting is x equals 0, so y plus z equals 5, negative 2y plus z equals negative 6. So we use first equation to minus subtract the second. Let me write it more clearly. This equals 5 minus negative 6. So we got 5 plus 2y equals 11. So 3y equals 11. So y equals 11 over 4. Okay, we got a y. So x equals 0. Y equals 11 over 3. How about a z? Well, we can solve z from the first equation in this set. 4 over 3. So the point at P, so P, the point is 0. Okay, and remember the direction vector V is 3, 4, next 7. So the parameterization for the point will be 0, 7 over 3, 4 over 3, plus t times 3, 4, negative 7. Then we are done.